Uh, is my screen visible?
Yes, it is crystal clear.
Okay. Yeah, good afternoon, everyone. Today we are going to have a webinar on a roadmap for aspiring bridge engineers organized by CE Career Connect. Before getting into the webinar, I would like to introduce about today's speaker, Mr. Vikram Singh, a highly skilled design engineer specialized in bridges and metro structures. Vikram sir holds a master's degree uh, from prestigious IIT Kanpur and has over 4 years of professional experience. He has worked extensively on the design of various types of bridges, ranging from box girder, PSC girder, steel plate girder bridge, along with extra dorsal and cable stayed bridges, which is considered to be the most difficult part of the bridges. Uh, he is currently associated with Tandon Consultancies as a design engineer. Before this, he worked as a design engineer at Larsen and Toubro, Chennai, in the Special Bridges Department of Transportation Infrastructure Unit, where he contributed to several key bridge projects. And some of his projects, some of his notable projects include Dhubri Pulbari Extra Dorsal Cable Stayed Bridge in Assam, the Vikramshila Setu Bridge in Bihar, and the second Ishwar Gupta Setu in West Bengal. And some of the metro projects are RVNL Kolkata Metro, Delhi Meerut RRTS, Agra Metro, Bhopal Metro, and his mastery of Indian and international standards like IS, IRS, IRC, Euro, and ASTO, along with his proficiency in advanced software such as MIDA Civil, makes him a true leader in this bridge engineering. And without further delay, let's onboard Vikram sir for today's webinar. Good afternoon, sir.
Yeah, good afternoon, and thank you very much for introducing myself.
Thank you, sir. Thank you for joining us. It's our pleasure to have you as our today's speaker. I hope the participants will learn a lot and will find a career path in bridges by the end of the session.
Yeah, I hope so. And I will make myself very clear, and I will try to explain each and every concept and questions they ask. I will make sure as much I know, I can explain to each and every participant, and they will feel benefit from this seminar.
Okay. I hope candidates who join, please utilize this session as much as possible, and you can ask the question and answers at the end of the session so that sir will be answering your questions. Okay, I think I can stop screen sharing.
Okay, so just give me a minute. I will start my presentation. Okay, so I hope my screen is very clear and visible to you, everyone.
Yes, it is visible, sir.
Thank you. Thanks for the confirmation. So today's webinar, we are including just a sec. I will just make myself comfortable with the screens because I have two. So I have to take care of everything here. Okay. So thank you very much, Vinay, for introducing myself. And today we are going to have a webinar over the topic, the bridge engineering. The broad topic is bridge engineering, but we will be covering a lot of things in this session, including from the introduction to the bridges, then what is a bridge, first of all. So starting from the topic, what is a bridge, what kind of bridges we have in our Indian history or Indian modern era, then what is the classification of bridges, then what are the components of bridges, then design and challenges, design and construction challenges. We will not be covering the architect part in this session because that's a separate and I'm not fluent with that. But all the things which we face in our real life challenges, what we see, what I have been working, what I face, what you may face, how you may aspire to be a bridge engineer, how you can work on the site, then the role of other variety or other branches of engineering in the bridge engineering domain. Then we will discuss about the career opportunities, how you can learn, where to learn, what road path you have to follow to become a bridge engineer. Then I will be providing at the last the references where you can go through and you will find a lot of knowledge from there. Okay. So even if you are in the bridges or not on the bridges, you are working in IRC, IGS, IRS, any kind of code, this session will be beneficial for you because I will make sure that the design, at least the construction challenges what we face on daily basis. Construction, a structure does not know whether it is for use for railway, highway or buildings. The structure is a simple structure. It all depends on the assumptions you are taking for the design purpose. So at the end, the number 6, 5 and 6, what you can see here, the comparison between 4, 5, 6 and 1, 1, 2, one of the major and best differences you can find out. Along with that, the Q&A session. Even if you are not in the bridges or anywhere in any industry, this session will be beneficial for you. So without further delay, let's continue. So before starting the session, let's make certain rules because we have several number of candidates and everyone will be asking their queries, questions. So please make sure that you ask all the questions at the end. Just note down the slide number if you have any questions in the slide. Then please sit in a mild, disturbed or severe silent zone because what I've been speaking, hardly 10% things are mentioned in the slides. 90% will be the speaking. And I will make sure and I will request everyone that please listen first, because if you don't listen, if you follow the slide, what is mentioned there, it will be, or it may be available with you on the later stage also. But anything what you miss from the listening, that may not be available because you may not be getting me every time or later on the later stage to clarify your questions. So continuing with that, let's start our session today. Introduction to the bridges. And before even the introduction, let's see a video. This is one of my first biggest and major infrastructure project I had worked on. We had hundreds of challenges there. So I will continue with this video and please watch it very carefully because we will be taking the reference of this video in the further slides. So half of the things, what I've been explaining to you, all that will be, you can grasp it when you watch this video very carefully. Okay. So I will just play this video and I will ask you if the audio is audible to you or not.
Hey guys, आप सबको स्वागत है हमारी ओर. Hey guys.
I hope it is audible to all of you.
Yes.
Yes, sir, audible.
Okay. Actually, sometimes Zoom meeting does remove the sound from the video. That's why I just thought to confirm.
आप सबको स्वागत है हमारी और एक न्यू ब्लॉग वीडियो में. हम आज आपको दिखाएंगे धुबरी टू फुलबारी ब्रिज. इससे पहले हमने बहुत सारा धुबरी टू फुलबारी ब्रिज का आपको वीडियो दिया हो, उसमें इतना कुछ नहीं दिखाया हो. यहाँ पर और भी ज़्यादा दूर हमने दिखाने के लिए कोशिश की आप लोगों को. जितना दूर हो सके आप देखिए एक बार वीडियो को, आपको अच्छा रहेगा. देखिए हम आपको यहाँ से दिखाया था, ये सब पहले भी दिखाया था और भी एक बार देख लीजिए. आपको यहाँ पर देखिए कितना सारा वर्कर काम कर रहे हैं. यहाँ पर एक बार देखिए
So your voice is not audible.
Okay, I'm sorry. So if you see this box cutter, the width of this box is 28 meter. It's a 6-lane bridge. In theory, it is called 4-lane, but it is designed as 6-lane. And if I just go back, you can see this box section at just above the pier. The depth of this section or the box cutter is 6.7 meter. Can you imagine 6.7? This is around 2-story building. So this is the scale of the projects you are going and watching here. And we will be taking the references of this in the further class slides to understand what we are learning in the
देखिए
session
कितना
today.
सारा वर्कर काम कर रहे हैं. यहाँ पर एक बार देखिए मटेरियल वगैरह देखिए कितना सारा मटेरियल. ये कितना बड़ा साइज का है, एक बार देखिए कितना. गाइस वीडियो अच्छे लगे तो लाइक शेयर कमेंट कीजिए. और बताइए आपको कैसा वीडियो देखना है ब्रिज के बारे में, वो भी हम आपको बना कर दिखाएंगे। यहाँ पर देखिए ये जो मटेरियल देख रही है ना नीचे की तरफ, ये कुछ प्रॉब्लम हुआ शायद इन लोगों ने, इसलिए ये फेंक दिया। देखिए इतना मजबूत है तो भी इन लोगों ने फेंक दिया, पता नहीं क्या प्रॉब्लम आया है इन लोगों का। यहाँ पर देखिए एक बार, देखिए कितना हाइट है ये ब्रिज, बहुत ज़्यादा हाइट है, काफ़ी ज़्यादा ही हाइट है। देखिए एक बार, वीडियो ज़्यादा बड़ा नहीं होगा, छोटा ही वीडियो होगा। देखिए एक बार, यहाँ पर देखिए ये जो मटेरियल लाते हैं, यहाँ पर देखिए वो गाड़ी को देखिए एक बार, कितना सारा टायर है इसके साथ। 150 से प्लस होगा इसका टायर, हमें पता नहीं, लेकिन 150 से ज़्यादा ही होगा, इतना देखकर लग रहा है। देखिए आगे की तरफ, हम इससे पहले आपको इतना से ही दूर दिखाए थे, ज़्यादा दूर देखा नहीं पाए थे। अभी देखिए यहाँ पर कितना दूर आया हो, एक बार देख लीजिए। ये सब का अभी तक काम स्टार्ट नहीं किया, लेकिन पूरा सारा के सारे पोस्ट जो है वो बांध चुका है। आपको वीडियो देखने से आपको समझ में आ जाएगा। देखिए हम इस थोड़ा वीडियो को फास्ट फॉरवर्ड कर दिया है, नहीं तो ज़्यादा लंबा हो जाएगा, आपको देखने में भी आपको बोर लगेगा। या फिर देखिए इस साइड भी जा सकती है, इस साइड उनके शायद कुछ काम वगैरह जो जहाज वगैरह है वो सब रखते हैं। यहाँ पर देखिए थोड़ी देर चलने के बाद हमने यहाँ पर ख़त्म जो ये जितना दूर है नदी के बीच आ गया है। यहाँ पर देखिए कितना सारा पोस्ट आगे भी है। देखिए एक पे कितना सारा पोस्ट है आगे की तरफ।
Sir, your voice is
Voice.
not audible.
I'm sorry, I forget this every time. I will not make mute it. So this segment you can see here, this has been cracked and it can't be used further. And this segment length is 2.4 meter. If the area of this box cutter is 20 meters square, just multiply by 2.4, how much it is? Around 48 meter square, 48 meter cube. And if I take even the 6,000 per meter cube cost of concrete to make it, you can even calculate how much does it cost. Even one single segment of the box cutter, if it fail, it will cost you a lot. And we are just talking about the concrete, but you can calculate the reinforcement also. You can see there was a lot of reinforcement in this. And furthermore, you can see the kind of machinery they are using. These are two heavy machineries to be utilized in a construction project. And later on, if you see here, this entire arrangement of steel stairs is anchored with the blocks here. So the equipment you are using, the material you are using, the reinforcement, and any big thing here impose a bigger challenge in the construction industry. So if you are in the design, it's okay. But if you are in the construction, you already know that there are thousands of challenges on site. That does not mean that there are no challenges in the design. The challenges in the design are different, but construction challenges are far apart and way beyond the imaginations. I will not explain everything here because there are a lot things to say. Someone has hit their arrow here. Can you remove it? On my screen, there are two arrows. Vinay, can you please take care of it? Who has marked these arrows?
No, why is that arrow coming?
Okay, we will continue with this.
Okay.
So this video, what you have seen here, this is a general arrangement drawing of that. This is actually a model, and you can see the dimension detailing. The lower pier is 16.7 meter and upper pier is even bigger than that. This is actually an hexagonal bridge. We have 4 cables on both sides, and the span of this bridge is 125 meter. So you already know that constructing a 125 meter bridge span is a big challenge in the construction industry itself. So this is how it looked like in the isometric view. So without further delaying our session, we will continue with the introductions of what is a bridge. In general, the bridge means the way of connecting the two places. So if you can connect the two places by any means, then it is termed as the bridge. A bridge is a structure brought forward under construction to surpass an obstacle. If you have something what you want to surpass from here, you have to construct a bridge. That does not mean bridge is the only way to connect the two places. You can connect by bridge, you can connect by tunnel, you can connect by other means also. But bridge is one of the best form. It is more economical than the other forms. A bridge is required without affecting the properties of obstacle significantly. If you can alter the properties of your obstacle, like there is a hilly region, if you can cut the entire hills, then what is the meaning of bridge? You don't need a tunnel, you don't need a bridge. You need a tunnel in that case because you want to dig inside the hills, right? So bridge and tunnels are the two ways of connecting the places by means of elevation or underground. Okay, it provides a passage over an obstacle. The bridge is an elevated structure, so it will provide the passage over the obstacle, and tunnel will provide you the passage under the obstacle. So you can see the few images here. And one of the biggest challenge construction industry has the construction underwater. Like in the seas, this is from MTHL, Mumbai Trans Harbour Link. And this you can see here, the double decker. First, like both tiers will be used for the, no, the lower tier is used as a flyover for the highways, and upper tier will be used for the metro trains, okay? So these are the types of bridges we had in the ancient history. Like they were using the ropes, they were using the branch trees, they used some of the wooden planks and tied with the ropes. All those kinds of bridges they had in the ancient times. But in the today's and modern era, we have far sophisticated bridges. So you can see we have like span to span simply supported bridges, arch bridges, cable stayed bridges, suspension bridges. Modern form of bridges is highly advanced. Then you can see these all the bridges are located in India. First one you already know. I'm pretty sure you know already this one. This one is Durgam Cheruvu. It is located in Hyderabad. Second one is taken from Delhi Metro, DMRC. Third one is from Nagpur Metro. And this last one is under construction Delhi Mumbai Expressway. So all these flyovers and bridges are existing in India in the real world. And the right to I have captured myself. So what are the different components in a bridge? If you see a bridge, you will see the piers, superstructure. Then these are far different from the buildings, what you see there. The substructure of a building is below the ground. But in case of bridges, the substructure itself is above the ground. So how do you identify what are the components of the bridges? What is a superstructure? What is a substructure, foundation? So you can see here, anything above the bearing. This is a general, very generic definition that anything above the bearing is called superstructure. But if you remember from that video, there was no bearing. Then how do you define? Anything above the pier, the vertical element, is called superstructure. Means the upper pier which is constructed above the deck in that video, that is also called the superstructure only. That is not a part of the substructure. So in general, anything above the bearing is called superstructure. And anything below the bearing is called substructure. I hope this much will be clear to you. And the superstructure in case of bridges is termed as girder. If you have listened very carefully, the introduction what Vinay had given, he mentioned the box girder, steel plate girder, PSC girder, and slab girder, slab bridges. So everything in the bridges, that is the superstructure, the slab part is called the girder. What kind of girder is that will be defined by the section of the girder, or the material of the girder, like steel or concrete, and box or PSC girder. So superstructure is termed as girder, but the name of that girder will be defined based on the material or the section geometry. So when you are traveling from the road, this is my road on the right, then you are traveling over the bridge. Then when you are traveling over the bridge, you will feel a sudden jerk because there is a gap. This gap is called expansion joint. Okay. Then you are running over this deck. You have handrails because a bridge is not only for the vehicles, it is also for the pedestrians. So we have the railings on the side. Then to support as substructure, we have pier. It is mentioned here. Then where you have on the one side where you have a road, and on the other side it is blank, like there is a river channel, right? So on the left there will be road. So to retain the soil of the road, not to permit that soil fall in the river channel, the structure constructed there, a heavy big structure, the kind of pier, that is called abutment. Okay. Then we have cross girder kind of things. A lot of things there are there, but the major elements are superstructure, substructure, foundation, and out of the substructure you have abutment and piers. Bearings is also included in the substructure, and substructure has one more thing, that is a pier cap. So when you are constructing a pier, you need to flare it to support all your bearings. So that structure is called the pier cap. Or let me draw it here, a small one, like this. So bottom element, this is termed as pier, and above element is termed as pier cap. So this is one of the cross section you can see for the superstructure. This is my PSC girder. We have deck slab. This is PSC I girder. Then you have the crash barrier. So when your economy permit, you go for the crash barrier, and when it does not permit, you can use a handrails, what it is shown in this image. Then there is a span comparison between the different types of girders. Like if there is 1 kilometer of bridge, I can construct either 10-meter span, 100 numbers, or 20-meter span, 50 numbers, 50-meter span, 20 numbers, 100-meter span, 10 numbers, 500-meter span, 2 numbers, and a single span of 1000 meter. Which one is economical for you? So when you are going to design a bridge, your first and foremost concern is to find out which geometry of structure is more suitable for your construction. Because if you remember the first video, that was an extra dose bridge. So why not we construct a normal RCC T-beam or PSCI girder? Because there was a special requirement. We need 100 meter of clearance between the two piers. So that will define my span length. So since the clearance requirement is 100 meter and my well diameter itself is 11 meter. So just to maintain that, we made and fixed the span of 125 meter. So if you are going to design a bridge, you have to identify which span length is more suitable for you. Now let's understand the importance of the bridge design engineer. That we have been talking about the construction industry. Now let's turn towards the design engineering. Just imagine, it may be some 30-40 meter span. Each girder weighs 70 tons. So that will account for approximately 25 meter tube of concrete, each girder, and there were some 8 or 9 girders. Now just see for yourself how much wastage they have done and what kind of error, which scale of error they have made here. Okay. So we need the bridge design engineer who can ensure that if you use this thing or this procedure, your bridge will remain serviceable, it will not collapse. But it is not the sole responsibility of the design engineer. As a design engineer, we can give the drawing, that this is my procedure of construction. You follow this and this bridge remains serviceable and it will not collapse. But what if the site engineer or the authorities working there, instead of M50 grade, they use M20? What will happen? So the responsibility of bridge serviceability is the like combined responsibility of a design engineer and a site engineer. The next thing you can see, this is one more bridge collapse. This is a recent one. I don't remember the name. It was in the Western India region. Now, let's understand what is a workflow in the construction industry. When you have a project, then how do we know how this project will be allotted? So first one is the client. Client can be your PWD, NHAI, MORTH. They want to construct a bridge or a infrastructure project in the country. So they will allot a tender. And especially here, we are talking about the EPC mode, engineering, procurement, construction. So I'm explaining the procedure of EPC contract. How does it behave? And most of the project in the today's era are allotted in EPC mode. So what happens here? The client will allot a tender. They will ask the contractors that we can pay you, but we need to construct a bridge. Now the contractors will calculate the cost of the bridge, how much they need to invest. They will quote a tender accordingly, like including their design cost, construction cost, machinery cost, their interest over the loan they take, everything they will include. And they will propose a final quotation that this is the money I need to construct this part of infrastructure. Then client will check who has bid the lowest and they will allot the tender to that contractor. Now the contractor has to hire the two consultants. One is the DDC, detailed design consultant, who will do the design of that project. Then there will be a proof check consultant who will check the design made by the DDC. And then client is a first party who does not know who has been hired or what they have done exactly in the design. So client will hire an authority engineer or called AE. He will check the design after it is designed by the DDC and checked by the proof checker. Then authority engineer will check the final design and he will approve the design. Only then your drawings will move forward to the contractor and then it will go to the site for the construction. So this is a procedure in a EPC mode. Then I hope you have heard this term AEC industry. So AEC stands for architecture, engineering, and construction. In the highway bridges, architecture plays a very minimal role, or most of the project, they don't play any role. Because when you are constructing a bridge, I need to decide what is the length of my span, what is the length of the total bridge, what is the height of the bridge. Architect does not play a significant role there until and unless you are preparing a structure which plays an aesthetic role. Just like Durgam Cheru Bridge, in the night, it has a very pleasant view. Architecture has to play a very important role in that. But in general, if you see the flyovers, architect does not play any role in that. So architect is not useful in the highway bridges, but it is compulsory in the metro bridges or metro stations. And it is very important in terms of buildings. You're already aware of it. So the planning of a structural and non-structural component with basic knowledge of engineering and construction, that is the role of an architect. Now, if you go to the engineering, let's say whether the architect is there or not, now it's the responsibility of engineer to design it. That does not mean the person who is working on the site is not an engineer. They are site engineers, but engineering here in this regard is termed as a design engineering. So engineering especially refers to the design engineer. And the responsibility of a design engineer is when you have a tender, like client float a tender that you give me your cost, how much money you need to construct this bridge. Now, contractor does not know what is the exact design procedure to be used in this construction. So he will hire a consultant. They will do their design and hand over to the contractor, and they will make the cost comparison and quote a tender. That is before the tender. But once the tender is allotted, now the consultant will make the detailed design of the same project. So there are two stages: design for tender and detailed design. Okay. Then comes the construction phase. Construction, there is no AE industry without construction. I hope you understand. If there is no construction, then what this architecture and engineer will do? Construction is the ultimate product and the real life product of engineering marvel, what you are creating at the end. And that will be handed over to the client. Client does not know what engineer has done, how they made the calculation, what architect did, how he made the calculation. The ultimate thing is when the bridge structure is handed over to the client knows that yes, this is the structure. It shall fulfill my purpose for next 100 years. Okay. Now coming to the design industry, there are a lot of softwares in the design field of bridge engineering. Out of that, the first three softwares we used in the design purpose. Like furthermore, 4, 5, 6 are also used for design, but 99% industry in the Indian market is using the first three softwares. But one problem is here, unlike the buildings where you model and design in the ETABS, we do not design the structure in the software because there are a lot of codes in the bridge engineering. I will show you also. And at least one of the code will be amended each quarter. You will have 4 to 5 amendments every year. And you cannot rely on the software that the software is also amended for that amendment received from the codal committee. So it is a general practice to analyze the structure in the software and design it in the Excel sheet. And analysis also does not mean that you input something in the software, get an output. You have to verify your analysis also, what you have been doing, that itself is correct or not. So this is a snip of the StatPro software. This is a snip from Midas Civil software. And if you see, the StatPro and Midas Civil are almost similar. You have the main menu, you have the geometry, view, select, specification, then type of the design, then material properties, specification, support. The similar kinds of options are available here. See, view, structure, properties, boundaries, load, analysis, similar options. The only thing is Midas has certain options which are not available in StatPro. One of the best thing about Midas Civil, let me write it here. The first thing is construction stage analysis. Unlike the buildings where you are designing the entire building and you do not check for the intermediate stage, the bridges need to be designed for the intermediate stage also. And I also think that the pre-stressed building structure also being designed and analyzed for the intermediate stage. Now, why we need this intermediate stage? When you have a gutter, there is no load. Then what pre-stress will do? Pre-stress will try to lift the gutter upward. So the tension will come on the top side. But when your bridge is in the static condition, you apply all the loads, the bridge will deflect downward. So what it is doing, the tension will shift to the bottom fibers. So you need to verify that due to the pre-stressing and all the loads, none of your concrete fibers goes under tension. None of the fibers goes under tension. That is a codal limit specified by the IRC 112. Then the third software is the Sophistic. This is also used in the Indian market, but not more than 5% consultants are using the software because there are some complexity in the software itself. Then there are a lot of design standards, and like the IS 456, the mother code for bridge engineering is IRC 112. The code for practice for concrete road bridges. We are especially talking about the concrete road bridges and any highway bridges which may be steel or concrete, but the deck slab always remain from the concrete. So there is hardly any possibility that IRC 112 will not be utilized for the design purpose. You may be using a lot of other standards, but IRC 112 remain as a mother code. So 112 is for the design. Then we have IRC 6 for the load calculation, just like IS 875. Then general guidelines are defined in IRC 5. Seismic design code is 114. The combined value of 1893 and 13920 is given in SP 114 in the highway codes. Then you have IRC 22. This is for the composite construction. Then you have IRC 78 for the foundations. SP 105, this is an explanatory code for IRC 112, just like we have SP 34. And then we have SP 65 for the segmental bridges. We have SP 66 for the continuous bridges. And the steel road bridges are designed based on IRC 24. So these are the basic codes for any bridge design. Then coming to the construction industry has a wider scope than the design industry, because you need the QA QC engineer there, you need billing, you need estimation, you need construction, and there are a lot more activities running on the side. Like side activities, we have procurement, then machinery department. There are a lot of departments and activities happening on the site. So since I have not been to the site, I'm not the correct person to guide you here, but there are a lot of things running on the site, and site has a wider scope than the design industry. And you will be aware of that when an industry or a company hires one design engineer, the contractor companies hire 10 site engineers. And site engineers, when I say that, does not mean only the site engineer. I am including QA, QC, billing, estimation, construction, procurement, machinery, everything. Now coming to the construction and execution of PSC iGutter. Until and unless you know the construction significance of the pre-stressed concrete, you cannot design it. In the today's day, in the morning also I had a lecture. I am teaching the pre-stressed concrete bridges, and I have been keeping the same sentence to each and every of my student, that the pre-stressed concrete bridge cannot be designed until unless you know how it will be constructed on the site. The pre-stressed concrete is designed based on the site consideration. It is not the design engineer's choice, whatever he want to do. It is the design engineer responsibility to follow all the procedures, all the equations, all the activities followed on the site to implement in the design purpose itself. So from the casting yard, you will be bringing your reinforcement, keeping over the casting bed. Then you attach your formwork. After the casting, you do the pre-stressing. Then after the pre-stressing on the site, this is a girder lifting. This is a girder lifting. This is deck slab. They're casting. Then you have the deck slab casting over the top. So there are different and lot of activities involved in the construction. And these are just the construction. What activities we have discussed in the last slide, those are even superior to this. So coming to this, let us see how a PSC iGutter is casted. But let's say first we understand the grouting procedure. Okay, so grouting is the final process of finishing the pre-stressing procedure. Once you input your tendons within the duct, then you have to introduce a cement slurry in the vicinity of pre-stressing tendons. Otherwise, the pre-stressing is also a steel. It may corrode. Okay. Now let's see what is the construction of a PSC eye girder.
दोस्तों ये आप देख रहे हैं ना, ये है भाई पीएससी गटर। पीएससी गटर की भाई कास्टिंग चल रही है इस टाइम पे। वो कास्टिंग कैसे की जाती है, कुछ इस टाइप से। पीएससी गटर के कास्टिंग से पहले सबसे पहले भाई गटर की शटरिंग और सपोर्ट एकदम प्रॉपर होने चाहिए। आरएमसी प्लांट से जो रेडी मिक्स कंक्रीट आता है उसको डाला जाता है बूम पंप में। बूम पंप से जो कंक्रीट आती है वो आती है भाई ये। दोस्तों इसको जो कंक्रीट करते हैं तो एक बार में भाई पूरा फुल नहीं करते, इसको लेयर वाइज लेयर करते हैं। इसको 3 लेयर में भाई ऊपर तक अपन फिल करेंगे। तो इसमें ये आप देख रहे हैं ना, ये चल रहा है शटर वाइब्रेटर, और वो जो ऊपर देख रहे हैं आप, ये है भाई नीडल वाइब्रेटर। इसको बहुत ज्यादा चलाया जाता है। पीएससी गटर के अंदर केबल डालने के लिए जो एचटीपी पाइप प्रोवाइड किया जाता है वो चौकअप ना हो, इसलिए भाई एक्स्ट्रा पीवीसी पाइप को आगे पीछे मूव किया जाता है, जिससे वो पाइप चौक नहीं होता। फाइनली भाई 3rd लेयर की जो कंक्रीट होने के बाद कुछ इस टाइप की सरफेस दिखने आती है। यहाँ पे भाई हमारा गटर कास्टिंग कंप्लीट हुआ।
So this was the procedure to construct a PSC eye girder for the bridges. The PSC eye girder, this is not the same image, but how do they construct and how do they transport on the site? That also you can see. This is a 30-meter span. Can you imagine how much long trailer you need to transport it and how much space you need to transport it? It is not the kind of girder you can just lift and keep over the trailer and move in the road. It is not possible. And on the bottom side, left bottom corner, you can see the placing of the girder with the help of cranes. Now let's see and understand the construction of a box girder bridge.
So your voice is not audible.
I will request you that you turn on your volume to the maximum amount, maybe 60-17% at least. Then you will get the full purity and the intent of this video. I hope you can see the scale of the project. Even to construct a 30-meter span, you need 60-meter length of launching gantry. So we need a specialized mechanical department to handle all this. Now let's turn towards the challenges in the bridge engineering industry. And challenges, these include all the challenges, what I could find about the designing, construction, and everything. First of all, the design challenges. When you have the pre-stressed concrete, designing it is not as easy as RCC. because we have to check and verify this in the intermediate stages also. Then local failure is very common in case of bridges. Site constraint, because the bridge design engineer cannot design a structure without knowing the site constraint. Long span bridges is another field and vast field to work and dedicate your career in the bridges. Then coming to the construction challenges, borehole collapse is one of the major challenge even as design engineer we face, because once a borehole collapse, I have to design my pile or well for the second location. It causes a secondary challenge. Underwater construction, you can see here, there's construction in the bridges, of the bridges in the sea area or in the rivers. Quality control, activity schedule, and leveling. These are some of the major challenges we face on the site. Then, especially in the quality control, when you are preparing the grade of concrete like M60 and M70, these require special attention to be prepared, and you have to follow a specific guideline to prepare the grade of concrete beyond M60. If you are preparing M70, then you need a specialized agency to prepare the M70 grade of design mixed concrete. Maintenance of heavy machinery is again a very big challenge. You have seen the Hydra machinery, the cranes, and a boom arm. A lot of machineries are working on the site, and if you do not handle all of them very carefully, accidents are very prone. So pre-stressing jack, the live wedges, launching entry, the transportation, what we had seen just before. Then maintenance of the bridge structure is paramount. If you construct a bridge, a design engineer designed the best bridge. Construction engineer, site engineer constructed one of the best bridges. But what if the plantation start growing in that concrete structure? It happens. I have seen at a lot of places. Then we have the separate department for this, and NHI is doing this, and Indian Railway has a separate department, Indian Railway Bridge Management System, taking care of the bridges and maintaining the bridges. Then we have environmental constraints like sustainability, water bodies, then wildlife, canals, marine life, you cannot disturb them, and socio-economic constraint that you need the cost to construct, how does it impact the society, and what kind of benefits you will get after the construction. Then this is one of the image. This is second Ishwagupta Setu in West Bengal. It is still under construction bridge, and you can see the construction is in a river, and they have brought a special machinery, we call it barge, to construct the foundation of that bridge. Then let's come to understand about the roles of other domains in the bridge engineering industry. We need a hydrologist, because when you are constructing a culvert, normal bridge or small span bridge, how much water will flow below that, you need a study of that. So you need a hydrologist. You need a mechanical engineer, because there are a lot of machinery working on the site. Then you need highway engineer. Highway engineer will ensure the signboards we have here, the light post, the railings, medians, everything, it is their duty. And what does bridge engineer do? Bridge engineer construct the structure up to here. This is the responsibility of a bridge engineer. That's it. This upper part is a highway engineer duty. We have dedicated highway engineers working on over these bridges. Now let's understand what is the role of geotechnical engineer. Testing of earth strata and to assess the quality of soil and bearing capacity of soil. This is the prime role, one of the major governing and primary role of a geotechnical engineer. Then when he tests the data, he has to provide his factual report and actual report to the structural engineer, who will be performing the software design and analysis and provide and prepare the drawings for the construction. Slope stabilization is one of the major challenges geotechnical engineers face. We'll see this in the next slide. And design of complex foundations. When you have a foundation which is not conventional, then you need a specialized agency who is expertise in geotechnical engineering. And also you need the geotechnical engineer to assess the local failure of earth during the construction. So you can see here, when you are constructing a highway, then you need to stabilize all these soil or rock. You need to stabilize all these rock with the help of rock anchor and soil anchor. And one of the best example of geotechnical engineers, you can see here, this is Chenab Bridge, and they have stabilized this stepped uh, hills here. Like you can see here, this is a continuous slope, but geotechnical engineers made a step like this. You can see these steps, right? To stabilize the hill at its location. Then they have introduced a rock bolter, just like what we are seeing on the left side. Then let's understand and come to the most important topic of the today's session. The career opportunity is bridge engineering industry. So this is just a funny video. Let's see this.
I am a civil engineer. It's an interesting course. It's an interesting course. They teach you a lot of good things. They teach you how to build buildings, how to construct bridges, how to build railway lines. The only thing they forgot to teach us is how to build a career out of this.
So if you also feel that you have learned a lot of things and is still stuck in your career, then we are going to discuss the same thing in the upcoming slide. So first of all, a lot of people ask me the question, is it worth pursuing the bridge engineering? One of the major questions, is it worth? If you are coming and joining this industry, bridge does not mean it is highway bridge or railway bridge. We will discuss it later. But any kind of bridge, if you want to pursue your career in the field of bridge engineering, is it worth for you? I will ask you certain questions regarding this. If you are curious to know what is running behind those panels, these panels we have everywhere in the construction of metros and highways. If you want to work on the most complex and challenging projects, if you are amazed by the large scale and mega projects, if you want to explore the world in the field of bridge engineering, because when I'm designing a bridge, it's not that I'm designing a bridge in Delhi only. To design a bridge in Delhi, I have to study lot of case studies in the entire world. How did they construct it? Is it failed or not? Is it standing till now? All those methodology I have to understand and then apply in my design. And if you want to earn the salary, most of people say this, somewhat I also agree that the salary of design engineers in the bridge engineering is slightly higher. I will not say double or triple, slightly higher than the other fellow engineers. If you are amazed by this, if you want to work in this, if you want to understand the complexity of the project, then the bridge engineering is waiting for you. And you can see the complexity also. You can see this element. This is my pier. And on the top of this, this is called pier cap. And on the right side, this is the pier cap reinforcement. If you want to learn how to do and how to design all those things, how to construct this thing, if you want to peek inside, you will not see anything. It is so dense reinforcement. If you want to work on this, if you want to learn this, then yes, bridge engineering industry is waiting for you. Now the next question, how much formal qualification you need? Do you need the BTech degree? Do you need a BE degree? Do you need a MTech or a MS or what? The big answer to this question is you don't need a master's degree in structural engineering to become a bridge design engineer. That is the first thing you have to tie with yourself, that you don't need a master's degree to become a structural engineer, bridge design engineer. I'm not right now. I will also not say that it is not even required, because out of the 100 companies, maybe 5 to 10 companies really need the master's degree only. If you want to pursue your career in those companies, then yes, you need the master's degree. But a lot of companies, even the big companies, don't need a master's in structural engineering to onboard you as a structural engineer in the bridge engineering. I hope you know this person, Atif Nawaz, Muhammad Atif Nawaz. He is currently working in Atkins Rallies in Bangalore office. And when he was asked this same question, he also replied the same thing. MTech is not a compulsion to be a structural engineer in the design. It all depends on your passion and how good you know the subjects. But one thing we both agree that as per the experience, after joining masters, you will be having more insight and in-depth of structural engineering subject. That is the only thing you will learn while joining and after joining your masters. If you want the in-depth skills, in-depth knowledge of a particular subjects only in the structural engineering, you join the masters in structural engineering. But if your passion is to design the structure, to work on the structures, you don't need a master's degree in this. Now, let's explore the different types of career options available for in the bridge engineering industry. So some of these career options are in the design, some of the construction, some in the BIM field. So let's proceed and understand what do you need and where you can explore your field. How to proceed to make a career in the bridge engineering? That is the first question. Because a lot of candidates, even among you who have joined the session, you either have a minimal experience, you have certain experience, or you are a fresher, beginners itself. So if you are a fresher and you are not getting a big consultants to work, then at least start from the local consultancy. I have several friends or several colleagues with me who started from a very big, small level, and today they are working with me. Within 4 years, they developed their skills at such a level that we both work together. Means I did my master's from IIT, he did his master's from somewhere, and one of them did not even do the master's. He pursued his BTech from a local college, and we 3 persons are working together in the same organization, sitting on the same desk. When you start from the local consultancy, you gather certain experience in the engineering field, be it design field or construction field. You have to gather certain experience and then you go to the big firms. And if you still want, you want to go for masters, then yes, that is also one of the options you have. But one of the thing I will suggest you, if you are going for the masters, then go for the tier 1 or tier 2 colleges, because below that your degree has very less meaning or the value. If you're going to a company with a BTech degree and a tier 3 or even below that your master's degree, your BTech degree has more significance as compared to your master's degree. So if you want to pursue it from the well and reputed colleges. Otherwise, start your career from a local consultancy and then move and shift to the big consulting firm or the MNCs. Now coming to what does a bridge engineer do? Bridge engineer, or we let's say call it structural engineer, their role is to design, coordination and detailing. Design is the design engineering. I get a project, I have to design it, how much reinforcement I need, how much concrete I need, what is the section dimension, shape, all those things. Then you need a detailing, how to provide a reinforcement and what is the anchorage length, bend zone, clashing of the reinforcement, all those things. And after that, we need a coordination also. Because I'm working as a design engineer, someone else is constructing on the site as a site engineer, then who will coordinate between two? Because I will not be going on the site, he will not be coming to the office. Then we need a third person. He is called as coordination engineer. He will be coordinating with the two parties and his role is to get the work done very smoothly. If site engineer is asking a query, then coordinator engineer will forward that to me. I will clarify, forward to the coordinator, and he will forward to the site. So role of coordinator is also to track the number of queries. Is it resolved or not? What is happening on the site? What is happening in the office? Both are running parallelly or not. All that work is the responsibility of a coordinator. Then you have the field of BIM. What you know as BIM, BIM in the buildings, that is termed as BRIM, Bridge Information Modeling in case of bridges. So you have drafting, modeling, and the same coordination there also. Now, the third part comes as a construction site. So you can work there as a site engineer, again the coordinator, and a QA/QC engineer. Then we have billing engineer, estimation quantity surveyor, lot of opportunities are available on site also. Now the question comes, if you're joining a bridge engineering, then which field do you need to go? You need to go for the highway bridges, you need to go for the railway bridges, or you need to go for the metros. I have been discussing this question to several juniors, seniors, and colleagues. Most of them prefer to go in the metros because they think the salary of a bridge engineer working in the metros is also slightly higher than the highways. They think so, but it all depends on your skills and qualifications, how much better you can present your skills on the table. If you can present your skills better on the table, you can extract even more salary than your metros also, even while working in the highways or railways. Now comes the biggest question. Do you need a certification in the bridge engineering? I am not in favor of those big companies who are teaching the bridge engineering and charging the lakhs of fees. Because I have seen and I have got the feedback from their students, current and past, that they do not deliver the skills and knowledge for which they charge. They are charging 2 lakhs, 3 lakhs. They can't even deliver the value of 10,000. So I don't personally recommend anyone to go for the certification. It is not compulsory. It is not recommended to pay the lakhs of rupees and stay there and do the certification requirement and fulfilling doing their task. Better to go on site, get yourself experience, and then join any company. If you are a fresher, go for internship. If you are in the college, you go for internship. If you are a fresher, go on site. Just request them whatever you pay, even 10,000. But don't look for site abroad your city. Look for a site engineering which is within your city. Request them, sir, whatever you can pay me, even the 10,000 rupees, I will work with you. Because within that 4 or 5 months of engineering, you will learn a lot of things which will make you capable of earning 20 and 25 or 30,000 per month just after 5 or 6 months only. If you want to gather that kind of skills, don't hesitate to join the site also. Even if you want to become a design engineer, you start your career either from local consultancy or start as a site engineer. Work for a few months, then go to a local consultancy. Since you know some of the factors in the bridges, local consultancy will not be bothering to hire you. Then when you learn for 1 or 2 years, then you start shifting to bigger companies and MNCs. Okay. But yes, I will say that if you have advantage, there's somewhere a bit, maybe 5% helps to increase your chances for the resume shortlisting. Please note the point. It helps you to increase maybe 5% chance to shortlist your resume in the interview. But when you are facing the interview, your certification has no meaning. All your skills, what you know, how do you know, how you present your skills on the table, that matters more than your certification. Now let's come to the BRIM. What kind of, how do we implement the information modeling in terms of the bridges? So the videos we are watching here, this is a Midas Civil Software. Midas is the parent company of that. And they are developing a CIM, Construction Information Modeling. And we have a lot of parties involved here. This is called Midas CIM. So all of these works and softwares combined with each other are being developed by the Midas company. And maybe within next 1 or 2 years, they will hand over this to the consultancies also. So now let's moving forward. Tips and tricks for the interviews when you are going in the bridge engineering interview. So when you are going for the bridge engineering interview, you don't need to have the prior understanding of bridge itself. If you are a fresher, if you are experienced, the case is different. But if you are a fresher, you don't need to be experienced in the bridges, or you don't need to be aware of IRC 112, because everyone know that, and every consultancy know that you have not studied bridge engineering in your academics. So it's already aware that you won't be knowing about the bridges. But what you need is, you shall have a basic understanding of IS 456. Okay, so what does it imply? If you are fluent in IS 456, if you know the basic code provisions of this code, which you have read in your academics, then company will be rest assured that when you start working on the bridges, you will learn the things, because ultimately company is there for their own profit. They are not for our profit. Now it's our responsibility how to make the company profitable to pay your salary. Okay, so they are watching in terms of the prior knowledge, what you have studied, that at least you know this or not. If you know this, that is well and good and sufficient for the interview. Next thing is construction activities. Even if you're going for the design engineering job, you have to be aware of the construction activities carried forward on the site. I'm not talking about the exact roles and responsibility. I'm not talking about the roles and responsibility. We are discussing about the construction activity. How do you construct the footing? How do you construct the pile? How do you construct the piers? How do you construct the superstructure? At least you would have seen. And if you know, because we have already discussed that when you're designing a bridge, the construction procedure becomes far more important than the design itself. Then if you're going on the site, then first and foremost, the primary skill is the drawing reading skill. Because if you're on the site, if you don't know how to read the drawing, then what you will get the constructed. So you shall be aware of how to read the drawing. And now when we say that read the drawing, that does not mean there is a section, there is a dimension. You were saying that you construct it. No, because when you are constructing a pier, a long bridge, the design engineer has given the coordinate of the piers, but he has not defined the shape of the piers. He defined, let's say, if I draw here, this is the pier. It is rectangle. This is, let's say, 2 meter. This is 1.5 meter. And this is the traffic direction. Okay. Now, the design engineer gives you the coordinate that you construct a pier over this location. But what is the probability that you constructed the pier in this direction only? What if you constructed the pier like this? This is my 2 meter and this is 1.5 meter. But you need to construct in this direction, right? So construction drawings, the drawing reading becomes far more important than any other field. Now, when you are trying to go in the bridges, we have a lot of seminars and webinars. Please attend those seminars to update your skills and keep on updated with the recent and new technology coming in this field. Then you need the basic understanding of mechanics, SOM, and structures. Be it site or construction, you need the basic understanding. And understanding of pre-stressed concrete concept becomes more important if you are directly targeting the big companies. Big companies, I mean the MNCs. If you're targeting MNCs, you have to be fluent in the pre-stressed concrete bridges, because you will be aware of any kind of flyover you see, any bridges you see. 90% bridges are pre-stressed now. We don't construct RCC bridges these days. Now coming to the references to learn the bridge engineering. These are certain books you can go through. First one is the Essential of Bridge Engineering. Essentials means it is a basic academic book you can go through. It will cover the basic bridge engineering, starting from your box culvert, RCC beam, PSC box cutter, PSC cutter, box cutter, extra dose, cable straight, suspension, everything it will cover, but to the basic theory. And this is the best book I have ever found in my career of 4 years of professional and uh, studying in the colleges. Now, if you're targeting the big companies and you need to understand the pre-stressed concrete, you can go through the pre-stressed concrete book written by N.K. Raju. This is working in terms of Indian scenario, and this is actually written in terms of IES. So what you can learn from here is how to design a pre-stressed concrete. But how to design the pre-stressed concrete for the bridges, some of the concept regarding that you will find in the first book, and you take the reference from the second one and follow the first one. It's like you know the bridges from the first, pre-stress from the second, and now it's your duty to combine both of knowledge together and learn the concept which is being used in the bridges. And if you want to go in depth in the bridges, then third book will help you the fundamentals. And this is a foreign author book. It will explain you a lot of things, but you need the basic understanding before that. So these three books are my favorite. And first one is the basic one. And I recommend it to each and every bridge engineer, aspiring bridge engineer, be it design or construction. The second thing is online courses. There are a lot of academies on the registered in the India. One is IA Structi, Indian Association of Structural Engineers. One is IABSE, International Association of Bridge and Structural Engineers. This is for the bridges. And CEAI, this is Consulting Engineering Association of India. So there are a lot more IIB, then ICI. There are a lot of institutes. You can join their seminars and webinar to upgrade your skills and knowledge in the field of bridge engineering. Then the third thing is, if you want the online lectures, you can go through NPTEL course, the bridge engineering taught by Professor Pyal Dhanbad. This is the best online lecture you will find in the field of bridge engineering. In fact, I have pursued this course personally on my own. Then the most important and best thing to learn the bridges is to go on site. If you can join a site and learn from the site, that is the paramount skill. You will never forget it, because that is an experience you will be feeling on the site. After 10 years, you will be remembering that I went on site in 2024 in the month of December. What you learned there, you will remember. You may not remember the online courses, but experience, you will always remember. Now, this is the last part of our session today. We have covered everything. We have covered the bridge engineering, the aspect, career field, growth, the resources to learn. Now comes the last part of our session today. We have discussed a lot of things. We have discussed what is a PSC gutter, box gutter, then the construction aspect, challenges, then the design. Design cannot be explained in a session, because unless you know the exact construction procedure, design has no meaning. Because if you forget even a single activity of construction, your design is entirely wrong. Because if you input 5 in the place of 4, your values will be reduced or increased by, if you put 5 in the place of 4, your values are increased by 25%. Okay. So if you demand the next session, we will take over the next session, maybe after a few months in the design field. But as of now, we are covering the construction aspect we have covered. Now, if you want to understand the design of concrete bridge structures, especially the pre-stressed concrete bridges, then I am myself teaching a live course. It is an ongoing course, and the experience of the candidates has been very overwhelming. And you have certain reasons to join this course if you are aspiring to become a bridge engineer. I have worked in L&T, And there we had several Korean experts guiding us on the field of bridges. So I have used the Indian codes, also American code, European code, and Canadian code, even to design the Indian structures. Because as I told you earlier, even to design a normal bridge structure at any location, you may be required to read and understand how the infrastructure projects are created throughout the world. Then the mentor, or you tell me myself, I have worked in the companies which are known for the best employees and best construction project in the history. Academically and professionally qualified, you can see my master's and BTech. I have 4 years of experience in the bridge design engineering. I have worked on several mega structure projects. The first one I have already shown you, the extra dose bridges, and the length of that bridge is actually 20 kilometer. 20 kilometer of extra dose and viaduct part, the 20-kilometer bridge. If you start running on the bridge, you will exit after 20 kilometer from the same bridge. So that was the scale of the project. And from the beginning of the career, I have been working on the pre-stressed concrete design. Complete pre-stressing procedure you will learn. Then in-depth knowledge of concept and design standards we have discussed earlier. And we have discussed a bit about MedACivil earlier. You will learn the MedACivil in depth, how much you need to analyze and design a bridge structure or pre-stressed concrete bridges. You will be provided with the live and recorded sessions. And one thing you have to note down that this is an advanced industry oriented course. This is not a basic course. You will not be learning what is shear force and what is bending moment. You will be directly designing the pre-stressed concrete bridges. Anything you need to design pre-stressed concrete bridges, that will be covered in the course, but you will not be taught what is shear force, what is bending moment, what is a deflected shape. And along with that, you will learn the modeling, analysis, conceptual understanding, along with the reinforcement detailing. Now, just a bit information about this course. If any of you want to join the course, then first and foremost, you have to follow the prerequisite of this course. My motto has been to teach the candidates up to the full extent I know. I am not the person just doing the business and getting some fees and my work is done. No, I have to take care of each and every individual. Like if you need to dedicate, if you have to dedicate, and if you can dedicate 8 to 10 hours per week, okay, only then you join. If you have a keen interest in the field of bridges, if you have a basic understanding of shear force and bending moment, if you have a research mindset, because bridge is a different field maybe for you, and if you want to understand something new, you shall have the power to grasp the new things. Then you will be given the assignment and quizzes you have to submit within timeline, and you will get a phone call every week, at least once. You may get 2 calls every week to explain what you have learned in the last classes. If you are willing to accept the challenges of the bridges, Civil Tree is just one phone call away from you. And your registration will not be confirmed just by your call. We will have an interaction session, maybe 20 to 30 minutes. Within that session, we will discuss if your goal and Civil Tree goal align in the same direction. Only then you will be given an opportunity to learn from this course. But one thing I will say, you have to plan your career. You have to plan your journey today to succeed tomorrow. Now, some of the benefits, the major benefits, what you can see here, you will get neat and clean sketches and equations. What you can see here, you will not find these kind of diagrams anywhere. Okay. These equations I have written by my hand, each and every equations. All these things, all the codal provisions you will get in terms of codal differences from where this formula is taken off. Then you will get a lot of images you have already seen in this presentation. You will get a lot of images in the session. Then you will learn the construction procedure to design a bridge. All the codal provisions used in the design will be covered in the session. You will learn all the required IRC design standards and codal provisions. You will learn the construction stage analysis, which is a paramount in case of pre-stressed concrete bridges. You will learn the manual design of the bridges along with the manual verification of the MedAS model. And this is a prototype of the structure we are carrying in our course. This course is termed as pre-stressed concrete bridges. So we are covering the superstructure design of PSC I-girder bridge and box girder bridge. So it will cover almost all of your pre-stressed concrete bridges types. Now coming to the most important thing. Whether you are in the bridges or not, whether you want to be in the bridges or not, it's up to you. But one thing you have to remember that IS 456 has defined the guidelines to prepare a design mix up to M60. Up to M60 only, and up to M60, if you know that the stress strain curve that is drawn here, the yield strain is 0.002 and ultimate failure strain is 0.0035. But what if your grade of concrete increases? What if you have M65 grade of concrete? What if you have M90? So what will happen? The ultimate strain, which you had 3.5 percentile, which is 0.0035, this will change to 0.0028 only. Means your ultimate failure strain will change with the increase in strength of the concrete, and your yield strain will increase as you increase the grade of concrete. So this will become 0.0024. So the value of 0.002 is changing to 0.0024, and ultimate strain of 0.0035 is changing to 0.0028. So the margin between the ultimate and yield stress itself reduces. This is the first finding when you increase the grade of concrete. And the second thing, one of the major thing, just give me a second. Where is it? Yes. Okay. I hope it is visible to you, right?
Yes.
Okay. So one of the major difference you will find between IS 456 and IRC 112 is their additional year. IS 456 was published in 2000, and IRC 112, the latest version is 2020. Now, why I am highlighting the publication year? Sorry? Any questions? Any questions? No? Okay. So you tell me, do you remember the assumption of IS 456, the limit state method? Can you tell me what is the minimum reinforced strain? What is the minimum tensile strain of the reinforcement? Can anyone please unmute yourself and tell me what is the minimum tensile strain in the reinforcement as per IS 456? Because maybe some of you are already working in the design field. Anyone? If you know, please tell me what is the fifth assumption of limit state method? Yes? Yes, please tell me. No? Okay, I will tell you. The minimum tensile strain of reinforcement as per IS 456 2000 shall be 0.002 plus 0.87 Fy upon ES, right? Now the question is, what is this 0.002? I hope at least you will be getting an idea. Can anyone tell me what is this 0.002? Anyone please tell me. If you don't, if you cannot explain this, how do I understand that you are getting the concept from this session?
Yield point?
Yeah. So in case of 456, FE 415 and FE 500, when we were working in the era of 2000, what was happening? The point of finding the yield stress of the reinforcement was not that easy. So what code says that you draw a point of 0.2% strain. You draw an initial tangent parallel line, and wherever it cut, that is the point of yield stress. Correct? So the sum of the first line, this first zone, and the second zone, this comes out to be 0.002 plus 0.87 Fy upon ES. Although 0.87 will not be captured in this image, but 0.87 Fy is the partial safety factor. So this is the failure strain in the reinforcement. But what if I tell you that in the modern era, it's been 2 decades, we have the procedure to find out the exact point of yield stress. Do I need to use that 0.02? We don't need it, right? So if I remove this 0.002, then if I calculate the actual limiting value, the same thing, I have just put the value Fe I have kept as 550. So if you calculate the actual limiting, this is 221, and this 221 is coming for an effective depth of 500. This is the assumption here, okay? This is my effective depth. If I assume my effective depth of 500, then actual limiting value is 221.8 as per IS 456 and 297.1 as per IRC 112. How does it affect? You can see the bending moment calculation at the bottom. The first one is 2310, and as per IRC 112, this is 2835. And if I use the calculator, just to explain you, this is 2835 minus 2310 divided by 2310. This is 22.7% higher. Okay. So there are certain differences in the design methodology of IS 456, IRC 112. The shear design of IRC 112 is totally different from IS 456. If you are aspiring to work in the bridge engineering industry, especially in the highways, then you will encounter totally different design procedures for the shear. In fact, I will say the basic remains same. Mechanics is constant for both of them, but the design standards, what is given in IS 456 and IRC 112, those are different. Okay, so half part is constant, half part is different. So that was the end of the session from my side. Thank you very much for joining this session. And now we will keep the forum open for question and answer session. Since you have already shared your questions in the Google form, so I would like to explain some of these questions first. We have 20 questions. Thereafter, the platform will be open to discuss the question from everyone. Okay. So the first question is the basic knowledge how to start a new career shift to a design engineer. We have already discussed this. Like all the questions I have kept as it is so that you know that your question was answered. But some of the questions we have already answered in the session. So the knowledge and all those things what you need, you can follow the slide from tips and tricks for the interview and the career growth page. Session on the superstructure. If you need a session on the superstructure as a webinar, we will arrange it very soon. But if you are intending to learn the superstructure in depth, what are the formula and all those things, then I will better recommend you to join the course. Please suggest 1 or 2 online learning resources, both for theory and software learning. Midas is one of the best software used in the industry of bridge engineering, but you will not find its video. You will find hundreds and thousands of videos about Midas Civil on YouTube, but nobody will guide you exactly what procedure you have to follow to design a particular bridge. They are more focused to teach you Midas, not how to design and analyze the bridge in Midas. And if you talk about the online courses for theory, then you can go through those books and the online resources I have already explained. Career building and opportunities for females in civil field. If you are asking this question, then I'm pretty sure that you don't want to go on the site. Then design engineering job is always open. You can start your career from a local consultancy, or if you have the skills and knowledge, you can approach the bigger consultancy and MNCs companies also. career as a bridge design engineer. So although we have discussed this question, but if you are aspiring to become a bridge engineer, first of all, if you are a fresher, don't worry, you go for the interview. You are not expected to know the concept about the bridges, the IRC 112 or SP 114. Nobody is expecting the same from you, but you shall have the basic skills from your academics. If you go with that, that is more than sufficient to crack the interview. What is the starting salary as a bridge design engineer? So it all depends on your skills, the company you go in, and the experience and the knowledge you bring on the tables. There are a lot of people who are starting from 10,000. There are a lot of people who work for 25,000. I have a lot of colleagues who have started their career with 25,000. And some of the companies, if you can join them or if they hire you, you can start your career at 40,000 also. So it all depends on your skills, knowledge, and the company you are going in. The future of bridge engineering profession. The future is very bright. Wherever you go, each and every city will be connected in the future. You can see the number of projects allotted and given the tenders in the current scenario. You can go through the MORTH website. You will find number of projects allotted in the field of bridge engineering. So this is a very growing field. Steps to upgrade, we have discussed. Key consideration in the seismic design of bridges. So seismic design is a big topic to discuss, but if I tell you in brief, then you need to first of all define what is your response reduction factor, because everything is related to the response reduction factor. If you are not using response reduction factor, if you're designing your structure for R equal to 1, then your headache is over. You don't need to do anything. But if you are using the response reduction factor, you have to use the overstrength factor. You have to design the foundations accordingly. You have to design the superstructure accordingly. And one more thing you have to take care, your structure is resting on the bearing or integral, because the design methodology for both types of structure will be different. See, I am answering all these questions based on what I understand from the question. If you think your question is not answered, then once the forum is open for you, you can ask, okay? So 9th point is just curious about the bridge design as I'm going to take it next semester. Good. Career for MTech fresher for bridge engineering, discussed. I have no experience in bridge design. How do I get started? Though I have done course from Midas, is there anything else that I should do to get the bridge design engineer role? First of all, one thing I will tell you, the course you have done from Midas, that is an added advantage for you, but not the only thing you need. If you don't have experience with bridge design, okay, you start from anywhere in the bridges. You start from the site, you start from the design, you start from local consultancy, or wherever the bridge is constructed, you just go there. The images I have shown you, the images I have captured, those are not my projects. I have not worked over them. I just went to the site, discussed with the site engineer that, bro, I just want to see this, and can you please allow me? Out of 10, at least 5 of the site engineer will allow you, right? Because you are also in the civil field, you understand the intricacies of the structures. So you go on the site and watch it. No need to go or see that you are not a concerned authority for that, you are not the design engineer for that. It's okay. You go on site, see the structure, how they are constructing, then you ask them that, bro, can you please show me the drawings also? Don't capture the images. Tell him that, brother, I will not capture the images. Just show me the drawing so that I can understand what you are constructing here. They will show you. So what you will gain from here, how to read the drawing and how it is getting executed on the site. That you will learn even without any job. Until unless you have at least this much of experience, how do you expecting someone to hire you at the bridge engineer role position? There are companies who hire, but there are companies who don't hire. So you target the companies based on the skills you have. Okay. So the next question is, okay, the next part was that, is there anything else that I should do to get the bridge design engineer role? There are a lot of things. If you want to be expert in the bridges, there are hundreds of things you can do. But the problem, but the thing is how much you want to go in depth. If you want to understand even more, we will get connected through a call, then we can discuss, particularly regarding your career itself. Which softwares are used for the bridge engineering? We have discussed already. What should be the minimum qualification? Done. Which Indian standard course used for it? Done. How to get a job for bridge design in MNC and Atkins? Okay, so how to get a job we have discussed. But my question to the person who sent this question is, why do you want to join Atkins, Jacobs and L&T only? Are you there? The person who asked this question, can you please tell me why do you want to join only these companies? No? Okay. So why I'm asking this, if you are aspiring to go in such companies, do you know their criteria? How do they select, or how do they hire? How do they take the interviews? What kind of questions they ask? Because until unless you know that, how do you imagine that you will be working there? And it's not only for the Atkins, Jacobs or L&T. This is applicable for each and every company. Until unless you know what kind of project the company do, what I will be asked in the interview, how I shall reply for that interview questions, then how you are thinking that you can get through that company itself. I'm talking irrespective of the name of the company, be it XYZ company. So you have to research it, find out what they are working on, and then pursue the career in that field. Next question, 13, scope and future of bridge engineer. Very bright. How to take independent project from firm and government organization. I don't want to answer this question because there is a lot of debate about it. If you want to understand, we can better connect over a call. Roles and responsibilities, we have discussed. Manual versus software approach for the design of the bridges. If you give me a bearing supported structure, the simply supported structure, okay, you tell me, you are aware of the bending moment and shear force for a simply supported beam. All the bridges, most of the bridges are simply supported. Can you design a bridge structure? If you're confident enough that you know simply supported bearing resting structure, can you design a structure, the bridge structure? It is really difficult. Why? Because we have understood that we can design it. We have something. But when you go to the design, you reach the design, you will find thousands of points which we never thought of earlier. So when you are going for the design, it is nor only manual, nor through the software only. It is a mixed approach. We have discussed also that you have to model it in the software, verify it manually, then design in the Excel sheet manually. Then soil mechanics and geotechnics structure analysis. What advanced topics should an engineer master, such as finite element analysis, load combination analysis, dynamic load effect, seismic and wind? Okay, so this is the second question. So if you're aspiring to become a bridge engineer, you have to be aware of all the terms you have mentioned, but you don't need to be an expertise in each and every field. Because the design engineering, the design of a structure is made based on certain code. There are certain guidelines already mentioned. I cannot deviate from it, because if I deviate, the client will ask me how you can deviate. It is not written in the code. So it is my obligation. I am forced to follow the code. I cannot apply my research. But where I can apply my research, something, the mechanics and analysis, which is not given in the code. What code gives? Code is giving you the design procedure. Code does not give the analysis procedure. So I will research myself for the analysis part. And if you are planning to do the research in that field, well and good, you will be on the top of the industry. But if you're researching for the design purpose, don't do it, because you have to adhere to the code. Second is seismic and wind engineering. How can engineers prepare bridge structures to withstand earthquake, wind forces, and other environmental loads? Hydraulic and environmental factors. What considerations are necessary for bridge over water bodies, including flood risk? Okay. So the second question is about the seismic. As I mentioned earlier, you have to follow certain guidelines, and the design procedure for these are already mentioned in the code. You cannot deviate from it. Everything is predefined. When you go to the hydraulics and environmental factors, then the bridges which are constructed in the river and sea. If you are aware of MCR, Mumbai Coastal Road, MTHL, Mumbai Trans Harbour Link, and the project I was showing you, that river is not flowing. It is not a perennial river, like very small, out of 20 kilometers, hardly 1 or 2 kilometers perennial. but other area remains dry. So that first video I was showing you, that is also being constructed in a river. Okay. So environmental conditions become significant, important. It may be severe exposure or extreme exposure. Flood risk, you have to design for it. Water current is not a big issue. Erosion control, uh, the geotechnical engineer will tell you how much scouring depth you have to consider while designing your structure. And if I tell you the bridge structure, what you have seen in the video, we have designed it in such a way that even 23 meter of depth is scour off. The bridge will stand at the location. The next question is how to grow in bridges and metro rail designing field as a design engineer and structure. Which software to be learned, how to gain best knowledge in that field. We have already covered. How a fresher can become expert in bridge engineering. The only way to become an expert is to gather knowledge. We have already given the references. We have already given the courses. You join those seminars, webinars, and keep on learning. That's the only way. And if you can go to the site, that is the best thing to become an expert. But don't think that you will become an expert in 5 months. It will take you years to become an expert. Career in bridge design, role shifting, we have discussed. How to start building career in the bridge engineering from the beginning and its scope, we have discussed. And the last question is ultra high performance fiber reinforced concrete. So ultra high performance concrete, when you use in your structure, the section depth will reduce. The area of concrete which you need earlier, let's say 1 meter square, now it may be required 0.4 or 0.3 or 0.5 meter square. So you have reduced the area, and when you reduce the area, your modulus of your moment of inertia will reduce. So the deflection becomes a primary important issue in the designing. That is one of the main reason why this UHPFRC is not being used even in the buildings and not in the bridges. Some of the projects they have used where it is not prone to the failures or it was not governing the design. But most of the locations we do not use this type of concrete because we cannot satisfy the core criteria while using this concrete. So that was all from my side. Now the forum is open to everyone. If you want to ask the questions, you are free to do that. No questions? Did I explain the session too well?
Yes, the session was really insightful.
Thank you. I hope every participant who joined the session got at least a basic understanding about the construction, how do they do,
Yes.
what they follow, the
Yes.
procedure, challenges, and a bit of the design. I could not explain it because until unless the construction is complete, the explain design is not possible. Any further queries from others?
So they are asking in chat box. I
Okay,
think they
so
don't have the access to on the mic, I think.
I think you have the access. Anyone can please try to unmute yourself and speak? Because they were doing in the beginning also.
Okay.
They have the access.
Yeah.
If you can ask me in the face-to-face, it will be better.
Or else I will repeat the questions which are asked in chat box.
Okay, so that no question is
Okay.
left out. But
Okay.
before that, I will request each and every participant to ask their question face-to-face, one-to-one.
It will be better for you.
Yeah.
Hello.
Yes.
Sir, I wanted to know that Midas is a designing software or modeling software like BIM or Revit.
Okay, I will just stop share. And what is your name?
Rahul.
Okay, so Rahul, the thing is that when you are using the Midas Civil, it is used for the analysis and design, just like ETABS and STAAD.Pro. But in the bridge engineering industry, we use Midas Civil only for the analysis purpose, not for the design, considering that we get at least one amendment every quarter and the softwares are not updated that frequently to design the structure. So we use Midas Civil only for the analysis, not for the design, and it is not a drafting software. For the drafting, we have seen the CIM, Midas CIM. That is a drafting software. Okay, next question. See, instead of mentioning a chat box, can you please ask yourself? I will
Hello?
better prefer that.
हेलो,
Yes,
am I audible sir?
yes, you are audible.
सर जैसे आपने बताया कि जैसे फ्रेशर को एक कोई कंसल्टेंसी देख के आप वो जॉब चालू कर सकते हैं और मतलब बेसिक लेवल से कर सकते हैं, बट एज एन एक्सपीरियंस पर्सन फ्रॉम द बिल्डिंग और एनी अदर सेक्टर, लेट्स से 2 years ऑफ एक्सपीरियंस,
Yes.
सो वो पर्सन तो अगर कोई कंसल्टेंसी में जाएगा तो वो सेम सैलरी भी अफोर्ड नहीं कर पाएगा, तो
Okay, so now let me ask you one
Practice.
question.
Yeah.
As a fresher, you have 2 years of experience in this industry.
Yeah.
If I give you a building, like what is the maximum number of floors you have designed?
Up to like I was working in the energy sector, sir, power sector.
Okay, so what is the maximum height of the structure you have designed for? Or what is the
Actually, sir,
maximum depth?
in renewables there is no much height structures. There
Like
are
what is the
really,
maximum height or maximum length of the structure you have designed for?
you can say like 2 story, 3 story. That is the maximum height for the buildings.
Okay, so if
Yeah.
I ask you that, can you design the same 2-story building without any support?
Yeah, definitely I can.
So if you have that skills and knowledge with you, if you come to the bridge field, anyone will hire you.
Okay. See, sir, actually, when we are applying somewhere, like in any opening or anywhere, anything like that, so no one will call us, and even our resume is not shortlisted because
See,
everyone is like mentioning
if it is
we
not
are only
shortlisted,
candidates from the
I understand. See, if it is not
background.
being shortlisted, then
Yeah.
you have to do one thing. Along with your current job, you on weekends you start going on the site, get some experience there, and when someone call you to hire shortlist your resume, you directly tell them that yes, I have done an internship in this field, or you have done internship somewhere, okay, not on the bridges, but is there anyone to verify where you have done this, you had worked on the buildings or not? So if you have that skill to bring on the table, if you can convince someone, you will be hired.
Okay.
Don't worry about that.
Understood. You
And
are
the
trying to
second
say
question,
go on the site, get some
yes,
actual knowledge, and
yes.
same
In fact,
explain the same thing in the interview.
Exactly. We have been discussing the same thing, that even if you are not in the design, if you are not in the bridges or engineering construction, just go on the site, ask the site engineer that, brother, can I please just see this structure? Just tell me, who will deny you to just to see the structure?
No, no,
That
no.
is the thing. And the
Yes.
second query, the modified version of your same question, if you are confident enough to design a structure as much you are intending and saying to say, but if you don't know, then the first thing is go on the site, learn it, then apply.
Okay.
But it's not, see, all the bridge engineers are not the by birth bridge engineer. They worked in some other field, then shifted to bridges. There are a lot many engineers like this.
Okay. Thank you.
So I will tell you a real case. One of my friend worked in the water treatment plant, then worked in the underground, and now working on the steel structures. Within 4 years, he is working in the third field. How? Because he has that confidence to convince others. That's it.
Thank you, sir.
You're welcome.
Hello,
Next
sir.
one.
Yes, sir.
Yes.
In slide number 26, in one image, I got a web section is very thin. Slide number 26.
22.
26.
26.
Yeah.
Okay. So if I don't show you that PPT, that section we have designed, that section you can see, this is around 300 mm, and this is sufficient to pass my design.
Okay.
Just a second. I'm getting certain. Okay. So in that slide, let me present it again, or let me present this again. This is 27, 26. So this section itself is sufficient to cater to my design forces. And if I tell you exactly, the wave width in this girder is 300 mm. Okay.
Okay, sir.
No. Next question.
So, sir, in one of your slide, in starting slides, pile cap thickness is very less. Like I have seen that pile on next slide. Next. Yeah,
Pile cap thickness.
yeah. In
Okay,
last
this one,
image,
right?
yeah, last image.
Yes, yes, yes.
Uh, pier cap thickness is very less.
This one, right? This one.
Pier cap.
Pier cap.
Yeah,
Okay, this one.
yeah.
So you can see this, it is very less, but this depth is 2 meter.
Okay.
So 2 meter is not less.
No, at the top, sir.
At the top, you are talking about this one, right?
Yeah, yeah, that thickness.
So this depth is around 1.5 or 1.6 meter. This one, this thickness.
Like, is it pre-stressed or it is a normal
It is
RCC?
pre-stress. It is post-tension pre-stress pier cap.
Okay, sir. Okay.
So the bottom pier cap and top pier cap both are post-tension.
Okay. Okay, sir. Thank you.
Okay.
Yeah, any more questions?
If there are no more questions, then we will start considering the chat box.
Hmm.
No questions? Okay. If there are no questions, then Vinay, yes, you can start from the beginning itself.
Okay. Hmm. Sir, can a diploma candidate can get into bridge engineering?
So when you talk about the bridge engineering, you have to bifurcate the parts. You are trying to go in the bridge design, bridge construction, or any associated field. Because in the associated field, which is not the core bridge engineering, even a diploma is much more than sufficient. You can go there. Just like RMC plant or a material industry. You don't need too much in-depth technical knowledge there. You can go very good. If you want to join the core industry, then you have to start from the site. And when you have 2-3 years of experience, then you can shift to the design. Because as a diploma engineer, there are a lot of things which are taught at the very basic level. So once you gather some experience, you will be having enough skills and knowledge to pursue your career in the design engineering also. So it's not like you can do it. You just have to gather certain skills and knowledge, and yes, you can do it.
And second question is, sir, could you please tell what are the sources to learn Midas software?
So YouTube is one of the platform where you can learn the Midas software. If your intention is to learn the Midas Civil software, YouTube is the best platform. But if you are tending to learn how to use the Midas Civil software in the analysis or design purpose, then there is no resource available. Because Midas company is more focused on selling their product. They will tell you how you can use the software, but they are not consulting engineers. They cannot guide you exactly how to design a structure. So I don't know the exact platform where you can learn the design of bridges in the Midas Civil. Just to know the Midas Civil, YouTube is the best platform. And if you still want to learn the bridges, then you can either turn towards my course, or you can search the online courses. But I'm not sure if someone is teaching the Midas Civil in the bridges along with that. Because a lot of people are still using designing the small scale bridges and using Stud Pro only. And if you are designing a 20 or 22 meter bridge, then you don't need Midas Civil also. Midas Civil is required especially when you are designing a pre-stressed concrete bridges. So yeah, there is no direct solution for this. If you want to learn, you can either connect with me later or we will find some other way, but there is no direct platform to learn the software. You can learn the bridges. There are a lot of platforms we have discussed earlier, but not for the software.
Okay. Third question is key details of your course.
Please, fees details.
Yes.
Please connect with me directly. We will discuss over the call.
And so can you suggest some local consultancy to apply jobs who have zero experience in bridge but have experience in building?
So local consultancy mean the local consultancy which is situated around your city or a state. If I'm sitting in Delhi, how would I know what is a consultancy situated in your city? So better you connect with your professors, the seniors, anyone who is either senior to you or teaching you or had mentor to you, you ask them, they can better explain you. But if you are in a Delhi region or Gurgaon, there are a lot of consultancy, Khanna designers, GR infra projects, HG infra projects, ASC Infratech, then big consultants are also there, Tandon Consultant, B&S Engineering. Then we have MNCs in the Gurgaon also. A lot of companies are there.
And the last question, not last one. What are the constraints of skew bridges in sites, in which bearings will be good for skew bridges which have an obtuse and acute angular ends?
Okay. So first coming to your second question, what is a bearing type? Bearing type is not defined by the type of structure. Bearing design is based on the loads coming over the bearings. And I hope you are in the community CE Career Connect, and you would have seen my reply over the question someone had asked. The bearing design is not dependent on the type of structure. It is dependent on the type of load it will be encountering. Now coming to your first question, what is the intricacy of skew bridges? So when you are designing a skew bridge, let's say we draw a skew bridge. So any kind of load you put here, here, or here, that will be captured by this corner only, right? So you need to provide the reinforcement in a congested reinforcement in this corner. If I draw in the plan, a bigger plan, then you need to provide all these reinforcement in this corner, and you have to take care of the wood armor bending moment also. If you are working in the Midas, you will be knowing this term. If you don't know, then when you have skew geometry, you have the out of plane deformations to take care of. And in terms of Midas, those are called the wood armor bending moments. I will write the name. This one, okay? Next.
And the last question is, sir, could you please explain your course details?
Explain?
Your course details.
Course detail, okay. Means someone is directly interested here. Okay, so we have discussed the prerequisite about the course. We have already discussed why you need to choose this civil tree. Civil tree is my institute name. And if you want to know exactly what we are covering in the course, then all the course content is mentioned here. We will be learning the analysis, modeling in the Midas Civil software, along with the manual verification. Then we will be learning the geometric properties. How do we decide what are the thumb rules? How do we decide the length of the bridge, span of the bridge, the depth of the girder, deck slab thickness, all those things. Then the time-dependent material properties. So the point is, let's say you have a pre-stress box girder or PSCI girder. You applied a pre-stress here, right? Don't you think this will compress? And if it compresses, means it will change the properties of the concrete itself. And what if there is a creep and shrinkage? All these things will lead to the losses of the pre-stress, right? shrinkage loss, and creep loss, relaxation loss. The losses of creep, shrinkage, and relaxation lies in the range of 200 to 250 MPa. Okay, so you cannot ignore it. That's why we have to understand the time-dependent material properties, how to utilize it, and how to interpret it. Then we will be learning the load calculation. What are the different types of load, the load calculation, then application in the MEDAS Civil. And later, when we apply it in the MEDAS Civil, after the analysis, we will understand how to verify it manually. Because if you can't verify your model has no meaning. Then we will understand the construction stage analysis. I had mentioned earlier also that any kind of bridges, especially if it is a pre-stressed concrete bridges, it cannot be designed without construction stage analysis. So this is the paramount study we have to make it. That is, construction stage analysis means what is happening during the construction, that we will learn. Then whatever we did in the software, we will understand what is the meaning of all those things. And in my current course, what my students also say that, sir, we were doing the design. We are in this industry maybe for 4 years or 6 years also. We were doing something, but today we got to know why we were doing all those things. So that is the most advantageous thing in the course, that you'll get to learn what is the reason behind using this clause. Then you will learn the pre-stressed concrete analysis, including your profiling, spalling reinforcement, busting reinforcement, the pre-stressed concrete design, including your properties, stresses, codal clauses, everything. Just like I had mentioned here in the next slide, VRDC equal to certain equation. And you see below this, as per clause 8.1.3, point number 2, in IRC SP 105 2015, formula given for calculating the shear capacity of section in this code is empirical only. How would you know this formula is empirical or not? So all those equations, I have gone through all the codes. I know the implications. I know the understanding of the code. I will bring each and exact equation and code provisions with you to share with you and to tell you that, yes, this is the exact procedure you have to follow to design and analyze your structure. Then after the analysis, we will be going for the design of PSC I-girder, PSC I-girder composite bridge. Then design of segmental box girder bridge. Both of them we have seen in our session today also. So our topic of the course is superstructure design of pre-stressed concrete bridges. So we are including both PSC I-girder bridge and segmental box girder bridge. So once you learn these two types of bridges, I'm pretty sure you will gain at least 80 to 90% of the entire bridge engineering industry in terms of pre-stressed concrete bridge design. Because these are the two most common form of the bridges in all the flyovers. You just exit from your home, watch any flyover, most probably 90% chances it is constructed with the either PSC I-girder or the box girder. That's why we have choose the topic pre-stressed concrete design of superstructure. Then we will learn the design of deck slab, box girder, segment, that is the longitudinal analysis, and the transverse analysis. When you are designing a slab, you design the slab for two-way. But in case of bridges, the two-way design is termed as, one direction is termed as longitudinal direction, one is termed as transverse direction. So we will learn both types of design, longitudinal design and transverse design. And along with that, you will learn all the codal provisions required for this design procedure. Each and every code, irrespective of it is small or big. All the codes, all the codal provisions you will find in the course itself. And along with that, you will learn all the codes like we have mentioned in our slides also. This is IRC 6, 112, 105, 114, 65. Any code which you need for the superstructure design of pre-stressed concrete bridges, you will find that in this course. Then one of the best advantage which people get in the course is phone call support. Any queries you have, you leave a WhatsApp message to me after the office hours. When you will be available, I will be available. I will call you and we will discuss the query over a phone call. There is no scope for the messaging. If it is a small query, I will reply on the message. But if I know that it will take 5 minutes, in the messaging, I will better clarify it in 1 minute over the phone call. So you get a phone call support throughout the course. After the course, you get phone call support plus messaging support, because most of your queries are already resolved during the course. And when you are revising the course after it is over, it's not like you will not get the queries. Since you will get the queries, you have the phone call support, but the number of queries will be lesser. So sometimes we will be discussing over the phone call, and sometimes we will be replying over the message. Then you will get the recordings of the session for 1 year's access, and interview guidance will be provided to all the interested candidates who want to pursue the course, who want to pursue their career in this field. Like who does not have a job in this field but want to pursue this field, you will get the career guidance. One point what I will like to highlight here, model file and Excel sheet will be shared. It will be shared, but first of that, when I'm explaining in the lecture, I will be showing you how to prepare an Excel file. So learning Excel and learning Midas are the associated part of our course. This course is not just about the pre-stress. This course is about pre-stress. This course is about the concrete. This course is about the bridges. This course is about the Midas Civil. And this course is also about the Microsoft Excel, how to utilize the Microsoft Excel for the design purpose. Because any course you go to YouTube or any other course, you will not find the use of Excel for the design purpose. That is one of the major USP of our course. Then the duration is 60 hours. The classes will be live. Earlier sessions are already recorded. If you join the course, you will go through the recorded version first. Then you will be joining the live classes simultaneously. And the classes are conducted on each Sunday 9 to 12. I hope that will suffice your requirement.
I hope all the queries are resolved and all the questions are answered. If any queries are there, you can answer it.
So any queries, if you have, then you can either send to me or send to Vinay, or you can leave in the Career Connect community. I'm also joined there. So I will be replying to your queries.
And I request everyone to on your camera once. We'll take
Yes.
a snap.
Everyone, please turn
Everyone, please turn on your camera. We'll take a screenshot. I hope the webinars we are conducting are helping to the students, and we will be conducting more webinars in different fields. Not only in bridges, we'll be conducting in bridges, in opportunities in USA, in everything. Not only particular field, we will be conducting in every field related to civil engineering.
Then I would like to thank CE Career Connect community for giving me an opportunity to present a session today. And I hope all the participants who are there and also who have left the session already, at least they were there up to the end of the Q&A session. So I thank you everyone for joining this course and this session. It's really wonderful opportunity to interact with all of you. Thank you.